Example 1. Starting with x1 is equal to 2, find the third approximation x3 to the root of the equation x cubed minus 2x minus 5 is equal to 0. Okay, so let's first write out this function. So we know that f of x is going to equal x cubed minus 2x minus 5. Okay. And so now what we want to do is we want to find the derivative of this function. Okay, so we want to find a derivative, so we want to find f prime of x. And f prime of x is going to equal 3x squared minus 2. Okay, so what's the given information? Okay, well, the information that we need are the following. Okay, we know that we're starting with x subscript 1 to be 2. Okay, so we know that x subscript 1 is going to equal 2. Okay, and then we also want to find what is f of 1. So if we plug in f of 1 into our function in step number 1, if we put in 1 cubed, so over here, if we find f of 1, that's going to equal 1 cubed minus 2 times 1 minus 5, and that's equal to negative 6. So that's going to be negative 6. Okay, and then we want to find f of 2. So if we plug in f of 2, that's going to be 2 cubed minus 2 times 2 minus 5, and that gives us a value of negative 1. So now we know that f of 2 is going to be negative 1. And then we want to find f of 3. So if we find f of 3, well, that's going to be 3 cubed minus 2 times 3 minus 5, and that's going to give us 16. Okay, so now what we want to do is we want to be able to use this formula now. So the formula, we want to apply the x subscript n plus 1. So the x n sub plus 1 is going to equal the following. It's going to be x subscript n minus, well, we're looking at the function f of x subscript n, so that means in the numerator we're going to have x subscript n cubed minus 2x subscript n minus 5, and then we're going to divide that by 3x subscript n squared minus 2. Okay, so what we want to do now is we're going to figure out when does n equal 1. So when n equals 1, that means that this now becomes x subscript 1 plus 1, which becomes x subscript 2. So now this becomes x subscript 1 minus x subscript 1 cubed minus 2 times x subscript 1 minus 5 over 3 times x subscript 1 squared minus 2. Okay? And so what do we know that x subscript 1 equals? Well, we know what it equals because up here we know that it's going to equal 2. So we're going to substitute x subscript 1 to be 2 for all of those values. So let's go ahead and do that. So we have x subscript 2, which is going to equal 2 minus, well, this is going to be 2 cubed minus 2 times 2 minus 5 over 3 times 2 squared minus 2. Okay, so when you multiply that all out, you're going to get the value of 2.1. Okay, so right now we solved for x subscript 2. Okay, and what we want to be able to find is x subscript 3. So now we're going to move on to next step number 6, So we're going to let n equal 2. So when n is equal to 2, we let x subscript 2 plus 1, which is then going to give us x subscript 3. Okay, so when it's x subscript 3, now it's going to equal x subscript 2 minus x subscript 2 cubed minus 2 times x subscript 2 minus 5 all over 3 times x subscript 2 squared minus 2. Okay, so now what do we know that x subscript 2 equals? Well, we know that it equals 2.1. So we're going to replace all the x subscript 2's with 2.1. So we get x subscript 3, which is equal to 2.1 minus 2.1 cubed minus 2 times 2.1 minus 5 all over 3 times 2.1 squared minus 2. And so we get approximately 2.09456. Okay, and we're going to approximate to 4 decimal places. So it's going to be 2.0946, which is accurate to 4 decimals. Okay, and so therefore we can see what x subscript 3 actually equals. Okay, now let's take a look at the graph. So if we take a look at the graph of this function here, okay, so what this graph tells us that it shows the geometry behind the first step in Newton's method in example 1. Since f prime of 2 is equal to 10, the tangent line to y equals x cubed minus 2x minus 5 is located at 2, negative 1. Has an equation of y which is equal to 10x minus 21. So its x-intercept is x subscript 2, which is equal to 2.1, which is what we found here. So therefore, to answer our question, we found that the third approximation to the root of that equation is approximately, to 4 decimal places, 2.0946.